Welcome everybody. My name is Luke Zarowski, and today I'm going to show you how to construct the circumcenter of a triangle using our compass ruler tool. So, what is the circumcenter of a triangle? Well, it is the point inside of a triangle where all three corners are the same distance. Well, why is it called the circumcenter then, and not the triangle center? Well, we know about three non-collinear points, which you can use to describe the points of a triangle, is that there's one unique circle where all three of these points line up and inhabit. So what we're actually finding here is not just the center of our triangle per se, but the center of a circle that our triangle inhabits. And so how do we go about finding this circumcenter? Well, what we know about our sides of this triangle is that none of them lie on this circumcenter, and so they're not radii or diameters, but in fact we can treat these as chords of a circle. And so what we know about chords is that they're perpendicular bisectors. If you do not recall about perpendicular bisectors, that is for a line segment, say ZY, a perpendicular bisector is the perpendicular line that obviously is perpendicular, but it perfectly splits Z and Y into two congruent line segments. What we know about chords is that their perpendicular bisectors go through the center of a circle. And so what we're going to be doing is we're going to find the perpendicular bisectors of all three of these lines in order to triangulate our circumcenter. If you've not watched the video on how to construct perpendicular bisectors, I'd recommend you go watch it. It is a great video. So today, let's start with, well, AC. Let's find the perpendicular bisector of AC. Now what we do is we set our distance of the compass. The distance does not necessarily matter, except it has to be greater than 1/2 of AC. Otherwise, our arcs will not meet up. And so we make an A arc right here. And remember, we do not change our distance of our compass, not just yet. We will do the same over here for C. And there's 2 points where they meet up at. And what we know about points is that we can always draw lines to them. And as a matter of fact, this line, by the way we constructed it, is our perpendicular bisector of AC. So our circumcenter, our center of our triangle or our circle, is somewhere on this line. But we don't know yet. It could be any of these points. Probably not down here, but it could be anywhere. So let's pick two more points, line segment, and find their perpendicular bisector. Now here again, it does not have to be the same distance you chose here for A and C. It could be any distance, as long as it is greater than 1/2 the distance of B and C. And so I'll pick this distance right here. An arc over here, and an arc over here. If these arcs get a little too confusing, it is always a good idea to erase them, because we no longer need those arcs. We constructed the arc for C, and now let's do the same for B here. And there you have it. We have 2 more points. And like all points, we can create a line segment between the 2 points. Again, this line segment is special because it's not just any line, it is the perpendicular bisector of BC. And actually, we're finished. We don't need to find the perpendicular bisector of AB because, well, right now there's only one point where our perpendicular bisectors can meet, and that is this location right here. So we could construct AB to confirm. As a matter of fact, let's go ahead and do that. Let's confirm for us that AB is the same distance. So actually, I'll just use the same arc that I created here for A. I'll just expand it a bit. And we'll use the same for B. And if we construct the line segment between these two, you'll notice it goes right through our circumcenter that we've already discovered. So you don't actually need to do this to do the perpendicular bisector of 3 line segments for our triangle. You only have to do it for 2, because there's only one point where all 3 of them can meet, or even one point where 2 of them can meet. So this is a useful tool if you're trying to prove E27 or E28, where we're actually trying to show about the perpendicular bisector of our circles. Thank you very much. I hope you learned something today, and have fun making triangles.